Thank you.
In Canada's Wonderland, there's a roller coaster that is a continuous series of identical hills that are 18 meters high from the ground. Platform to get on the right is on top of the first hill. It takes 3 seconds for the coaster to reach the bottom of the hill 2 meters off the ground. So if we know how long it takes to get from the peak to the minimum, that's going to help us identify the full period, right? How much of the period has been covered if we're doing a cosine graph and we reach from peak to minimum? Half, yeah. So we know it's going to go back to the maximum at 6. So we kind of use that information to kind of help us out. That's right, 6 will be the period. You can obviously count to figure out what the d-value is. There's also a formula. You can just find the average of the max and mins. That will take you to their d-value as well. Okay, this is an easier graph because we don't have to worry about any phase shift, right? It starts perfectly with the cosine, not even the reflection. It's only have to find the A value, the B value, and the D value, right? We have everything that we need here. Okay, any questions with part B? And in part C, you're just entering 11 into the variable. You can use t or theta or x. Any variable is fine. Make sure you're in radian mode. Practice entering into your calculator. Let me know if you have any questions. Okay. So we'll go to ideas. Sure you guys know if you're using a 36. Also, you see at the very top, you'll see this RAD to indicate that you're in the right mode. But if you're not sure, you can also go to mode and then make sure that RAD is highlighted and not DEG. Okay. All right, number 2 is a little bit more involved because there will be a phase shift and we have to use sine. Okay, so let's read number 2 here. Okay, so the swinging back and forth is causing that oscillation, that change from the minimum to the maximum distance. So we know that at 3 seconds, it's going to be at the lowest point, 4 meters from the window. And then at the highest point, it'll be 20 meters. So regardless of whether it's sine or cosine, if we're going from minimum to max or max to min, how much of the period have we covered? Half, right? So what's going to be the full period? 8, right? Doesn't matter if it's shifted or cosine or sine. We know that if we can find a max and a min, that distance between them horizontally is going to be half the period, right? Okay, does that make sense? Okay, so 7 minus 3 is 4. So, if I go another 4 units, it's going to finish this cycle. Oops, sorry, 4 meters from the window. I put 2 there, should be 4. The midline is 12, halfway between 4 and 20. I think something that also helps is doing the interval, right? Because we don't really have the interval defined, but I think it's going to help, especially we're going to have to, you know, kind of transition this to a sine function. And this kind of right now, this feels more like a shifted cosine graph, right? So I think it really helps if we do our interval here. So interval is 1/4 times the period. So if you think about a 5 number system, right, we can kind of map out all the subintervals here. We know that if we're at the minimum, that each of our points is going to be 2 units away. So minimum to midline to max to midline, they're all going to be 2 units away. So we can kind of use that to kind of build out our graph a little bit. Okay, we may be graphing more than we need, but I think it helps to just have a view of the full graph, or maybe more than that. Okay, b equals pi over 4. Gather our d value and our a value. Okay, do you guys see a picture of the sine graph? Okay. I mean, we could start here and do a reflected version, or we can start here and make it the original. So it's really up to you, but maybe it just feels more straightforward to picture a sine graph. So why don't we write the equation for this sine function as if it were starting at the y-axis, and then we can worry about the shift. So we should be able to just, you know, fill in the a, the b, and the d value, and then we can worry about the shift at the end. So oops, it says distance, so you can use y if you want. I'm just gonna use d of t, but yeah, you can use y equals or use x and y. It's fine as well. Okay. Running out of room here. Okay, so I left out that blank because I want to just make sure that we understand this graph is really for the sine graph starting at 0. And how far and what direction do we have to shift to make it turn into this graph that we see in front of us? To the right 5 units, good. So plus or minus 5? Minus 5. Right. Does that make sense? Where you're always picturing your sine or cosine graph from the origin. And then once you have that created, then shift that that graph you have in your mind to where it's going to land with the graph that we want.
-8 sine I4 times theta minus 1 would also.
That also works. Good. Yeah, that's another option. I'll put that down as well. Yeah, you can also think of it as, okay, here's a reflected sine graph, and I'm just going to start at my original location, shift it to the right one, and reflect it. So that is also acceptable. Okay. When is the first time he reaches 16 meters? We can just look at the graph. I mean, it's not going to be exact. Looks like it's around a third or 0.3. You know, somewhere between 0 and 1. So I have t equals 1/3 seconds, but any estimation is fine as long as you're kind of within that range. You know, it's going to be somewhere between 0 and 1. Okay, questions? All right, try number 3. All right, does anybody still need to look at this page? Everybody okay? Okay. John is floating on a tube in a wave tank at 1 second. John reaches maximum height of 14 meters. At 9 seconds, he's minimum height of 2 meters. What do you think the period is? 16. I got 16. So max starts at 1, ends minimum is at 9, so that difference is 8. We know that the distance, horizontal distance, is going to be half the period from peak to valley or from valley to peak. Double that, and we have the full period. 8 plus 8 is 16. Okay, they're asking us to write a cosine function. It's pretty close to a cosine function. It should be an easy shift. Okay, see if you can find your b value and your a value. If you want, you can find the interval.
What number does it say? Is that
Oh, this is 17. Yeah, so there's my full period. 17 minus 1 is 16. Didn't have to graph it all the way, just wanted to kind of see it. Okay, so we think of cosine as starting at the max on the y-axis, and that's what I have in front of me. But I want to shift that graph to this location, so what's my shift?
the right one?
So therefore, minus 1. Okay, hopefully you guys are feeling more comfortable with the shift. Okay, and now it's just plugging in 21 and for t into the calculator. Okay, if you get done with 3, then read number 4. Yes. Okay, this will line up very nicely with the cosine function, right? Number 4 will, but after we create our cosine function, we'll have to do a little bit of a shift though. Okay, what's our period? 2. Because we have to convert to sine later, it helps to have that subinterval, right? That subinterval is going to help us know how far to shift left and right. So I'm going to find that information as well. Okay, cosine function is easier, don't have to worry about a shift. So for the sine function, you have 2 options. Either pick the closer one and then do a reflection, or pick the further one and then do a positive. So I'll write down both equations. Either one is fine. But do you guys see a full sine graph here? Your A, your B, your D value all stays the same. Just that little bit of a shift here. So if I wanted to target this one, what would my shift be? Well, I need to start here, right? So this equation is for one that starts at, good, 1.5, because it's 1, 2, 3 subintervals over. You can kind of look at the graph, right? It's like 1.5 or 3 over 2. Plus or minus. Minus. Okay, there's another option. Another option is you can start here and then just do a reflected version. So I'll write that down as well. Here for D, you're just making your best estimation between 2 and 3. Look to see where it's around 15. My estimation is 2.7, but anything around there is fine. Okay, how are we doing so far? Okay. Page 36. Hi, does anybody still need page 35? Okay, try number 5. Okay, so Sam is riding his bike. One day, picks up a nail in his tire. The nail hits the ground every 2 seconds and reaches a maximum height of 48 centimeters. Use the information to sketch a diagram of the sinusoidal movement. So just from this information here, the nail hits the ground every 2 seconds. What does that tell us? That period is 2. Yep. All right, it's going to cycle back to from ground to ground. So 2 second period is 2. Okay, since I got to deal with a sine function, I'm going to go ahead and find my interval. I think it helps. Okay, so I spaced it out here. Every interval is 1/2, just easier for me to track my movement here. Okay, cosine function is easier. There's no shift, but there is a what? There's a reflection, right? It doesn't start at the peak, it starts at the minimum here. Okay, do you see a sine graph nearby? So I'm going to create a sine function that starts at 0, and I'll worry about the shift. So this sine is this imaginary graph that I have in my head that starts at 0, but what's my shift going to be? Yeah, shift to the right one to make it match this graph that I want. Starts at 0 to the right one. Good. Oh, so I'm sorry. Right one interval. What's my interval going to be? Yeah, interval is 1/2. Okay, 0.5. Sorry. Or we can do 0.5 and for 1/2. Okay, number 6. What's the period here? 4. Looks like this lines up nicer with the sine graph. You can fill out the sine graph first if you like. Oh, sorry, 2.75. My A is 1.25. Yeah, I did sine first just because I know it's the easier one to do without any shift. My cosine graph is nearby. Shift it right to the right one. Either equation will help us get to the height of the rope. All right, number 7. Does anybody still need this? Oh, hold on a second. Yes. Oh, you got 0.345? What'd you guys get? 0.345. Okay, let me double check that. I may have entered it wrong. Okay, I'll put the rest of the key on the website, and morning review, and I'll do a fourth period review as well. I'm gonna try to put together a worksheet. If I do, I'll put it on the website, and I will send you guys a reminder. Have a great weekend. Bye, thank you. Have a good weekend. See you guys. Bye. You too.
Do you like this? It's like a finger. You put it on your finger.
Okay, that's.
And it has like a bunny. So,
I'll give you $20. Yeah. Get mad, right? Get mad. Our first about to get in. Somebody else. Wait till wait turn.